Water in the subsurface can exist in two very different states. It can exist in the saturated zone, where all of the pores are filled with water and there's no air, or it can exist in an unsaturated state, where there's a mixture of air and water in the pores. We're going to spend the next few videos talking about how water occurs and moves in the unsaturated zone. But first, let's draw a picture kind of defining the zone that we're talking about. So imagine that this here was the ground surface. We're going to draw a vertical cross section. And we've put in a monitoring borehole, and we've installed a well, which is continuously slotted along its entire length, so water is free to enter and leave. And we observe in this well a water table. So it's the water level, it's the level to which water just rises here, denoted again with this upside down triangle. This is the water table. And we know that below the water table, it's saturated. You have groundwater. This is also sometimes called the phreatic zone. And somewhere up here, it's unsaturated. But it turns out that the distinction between the saturated and the unsaturated zone does not really perfectly align with the water table in most circumstances. And that's because there's a zone above where the water table is, where the pores are they can still actually be totally filled with water. And this zone is known as the capillary fringe. And it's where the water is being pulled or wicked upwards by the material that it occurs in. If I were to draw a plot over here, and this plot is a function of depth on the vertical axis, and on the horizontal axis it's a function of theta, or volumetric water content, and I were to label here the porosity of the subsurface, draw these lines over, we know that below the water table we're saturated. We know that somewhere up here we're unsaturated, so the volumetric water content is less than the porosity. But it turns out that within the capillary fringe, all of the pores are still filled. So this is sort of an intermediate zone that we'll talk a little bit about in the coming videos. And we'll also talk about why it is that the water gets pulled up here. So this zone here is sometimes referred to as the tension saturated zone. And I think in the Dingman textbook, it's referred to as the intermediate zone. So remember that at the water table, the atmospheric pressure, the pressure of the water is equal to the atmospheric pressure. Below that, it's positive. Above this, it's actually negative, so the water is under some tension. And that's where this term tension saturated comes from.